In video number 277, you saw the first part of my Danube River Mailbag. During 5 weeks, we biked 3,000 kilometers from Germany to the Black Sea. In this time, the mailbag was filled and filled. Today, you will see part 2. Grüezi YouTubers, here is the guy with the Swiss accent, with a new episode and fresh ideas around sensors and microcontrollers. Remember, if you subscribe, you will always sit in the first row. Next one. What the hell is this, you might ask yourself. So let's check what it is. You probably wouldn't have expected that. This is a microphone and it has a I2S interface. And it is a MEMS microphone. Now MEMS is an interesting technology and it is for an ESP32. And why for an ESP32? Because the ESP32 also have an I2S interface. Now what are MEMS microphones? Now MEMS stands for microelectromechanical systems, and microphones are just one example of those new devices. They can be manufactured the same way as integrated circuits, so in high series, very small and also quite cheap. They have a high signal to noise ratio, low power consumption, good sensitivity, and are available in small packages. All advantages for our applications. I plan to do a video about those MEMS microphones because also Adafruit had one of those in their product range, but it was not completely compatible with the ESP32. Now this one should be completely compatible. We will see this in this video. The next one came with DHL and it was a gift. I did not order it. So let's see what's inside. A Maix dock. It has a camera and a display and AI inside. So captured artificial intelligence. Fortunately not intelligence as such, only artificial intelligence. And the other one is a Lychee Pi Nano ARM development board. So let's have a look at this one first. Here is the listing of this kit. There are a few interesting things here. The first thing is the price, $19 for a CPU, a quite capable CPU as we will see later on, a camera and an LCD. This is the first interesting thing, and the second interesting thing is that this CPU used here is a KPU K210. The CPU used here is a RISC-V CPU. What is special here? RISC-V is an open source chip architecture and its intention is to replace proprietary chips in this field. The speed of the CPU is quite high, 400 or 800 megahertz, and it has also neural networks somehow inside, so a lot of interesting stuff here. It has an audio processor and even a field programmable I/O array. So this is a quite capable CPU, but of course it will have a steep learning curve, I assume. So I have to look into it before I can use it, I assume. If we have a look at the design, we see this RISC-V CPUs, the accelerators here, and we even see an ESP8285 Wi-Fi module, which explains this small IPX connector and the antenna here. So this chip is programmable in Python or in MicroPython or something like that. And I entered a few commands, and now you see the camera takes pictures and the display shows it. Very cool. So this board runs. It's pretty fast, I have to admit. I think this board includes a lot of fun here. But as I mentioned, it needs some learning. Anyway, thank you, Seeds, for this kit. The other board is a Litchi Pi Nano with an ARM CPU. This now is a typical proprietary architecture from ARM, and it is incredibly small Linux systems. Now, I'm not sure if I will try this out because I'm not a Linux specialist, and from what I saw in the internet, it needs a lot of knowledge to use this one here. So maybe I stay with my Raspberry Pi for the moment, and we'll try this one when it's a little bit more advanced. I'm pretty sure I did not order this one here, and I do not exactly know what it is. This seems to be a maker Phat for the Raspberry Pi. To take it out, pull this strip. That's okay. Nice packaging, I have to admit. And here it's accessories inside. Press and lift. Strange. No description. Next one. Also really nice packaging. Seems to be an Arduino. There is something special here, digital PWM, some transistors here, which are not usually on an Arduino. Two buttons, one is the reset and a second button, and here a buzzer. And interesting, a slide switch to mute the buzzer. If you are annoyed, you can mute it. They have indicator LEDs here, and these transistors here are most probably to switch these LEDs. So this seems to be made for shuls, and it's produced in Malaysia here. Cyton is a Malaysian, I think the biggest Malaysian distributor. There is a QR code here, so maybe we can find more. So I found the information. Nice looking young guys here with a tie, which is rare in the Western world, I think. Anyway, the usual stuff, I think. Yes, the usual Arduino stuff, which is not very interesting for us, but if you have a young kid or so, it should find the information here. Obviously some preloaded software. Maybe this will become my favorite Arduino Uno board because of these LEDs here. Sometimes it's nice if you do not have to connect always an LED to do some checks if they are already built in. This is a clear and added value for me. And sometimes you need also a button. So these are two nice features for me. The buzzer is probably not as much important. But anyway, nice to have maybe. The Pi Hat is made for the Pi Zero. It has the same form factor, and I discovered something very interesting. I didn't know that it exists. This pin header here is completely different to what I know, because it is mounted as surface mount on top of the PCB, but it has quite big holes and it is mounted like that. This gives a very compact dimension here because we do not lose any space. These pin headers I have to check if I find them somewhere. They can be interesting also for other projects. And the rest is the usual stuff: LEDs, buzzer, here USB to serial adapter, and 3 buttons. The price for the Phat is about $10 roughly, and the Arduino is roughly $6. I do not know if they ship internationally and how much it is. One thing is different to the normal Chinese suppliers. They have a young and fresh looking design. I like it. The next one, a digital Gauss meter. The Gauss meter looks like that. And here is the probe. And it needs a 9-volt battery. I saw this meter the first time on a YouTube channel from Ben Krasnov, Applied Science. And since I'm not able to measure Gauss in this lab, I can measure many other things, but Gauss I was not able to measure so far. So I thought I add this capability here. I have no particular need for it. I just plan to do some experiments with magnets and inductors and stuff like that. So I got a magnet here, and I have to get the probe out of this protective case, and this is the probe here. It is a Hall sensor, as we have it also for our switches. Maybe you see it here a little bit. It's a very small sensor here, and now we can measure. We have 2 ranges, 2 Tesla or 200 millitesla. And because this is a neodymium or something magnet, a very strong magnet, we see we have 160, depends a little bit where I place it, 238 millitesla, and it's quite delicate where you place it. So like that we have about 250 millitesla, and if I turn it by 90 degrees, we have close to 0, and if I turn it, we again have this 250 or so millitesla, and we have here the S, which means it's south. And if I turn it, now it's north. So you see, it works. Now I have another beast. These magnets are so strong I was not able to separate them easily. Now let's measure this one. They have 520 millitesla. On this side it's south, and on this side it's north. So it looks that this Tesla meter works, or Gauss meter. Gauss and Tesla describe the same value, but they are different. Nice addition to my lab. Now I can measure magnets. Next one. Lots of material here. I think I know why they package it so well. Because it is a very delicate device. It is a 7.5-inch e-paper. Now, why did I buy this e-paper? We had some discussions about user interface when I did my device which warns us if it's cold or rainy outside. So many people asked me why the hell you didn't do a e-paper, and I had to admit I didn't do an e-paper because I didn't have one. Now I have one, and I have a big one. And here it's an SPI interface, either 3-line or 4-line. I have to pay attention because it's not like a normal display. It is very, very thin and has no protection at all. So this is how it came. And now I connected it to the driver or to the interface board. I assume there is something on it. And now I uploaded the sketch to an Arduino Mega because the demonstration sketch was too big for an Arduino Uno. So I had to use a Mega, and now we will see what happens. Now it changes something. Aha, now it works. It has no red anymore, but at least now I've found a way to connect it to the Arduino Mega. It seems to work. But the library I found was not really a library, it just displayed one picture. Now interestingly is also that here we have the connections for the Raspberry Pi. So these displays can be used on a Raspberry Pi or on an Arduino Mega, not on an Arduino, on a normal Arduino, and probably also on an ESP32 because it has more memory space, so it should be okay for that. But now I have to find a real library where I can do some designs. Next one, and it's from Waveshare. Also very well packaged. So this one is mounted on a PCB, and some sort of driver is already here. It's also an SPI driver, and it's only 4.2 inch. And this is the nice thing on the e-papers. They keep whatever you put on them without any voltage. So I have now two different size e-paper, and I cannot have an excuse I didn't use a e-paper because I didn't have one in my lab. The next one is already unpackaged. It seems to come from Sparkfun, but in reality it comes from a viewer who wrote that he works for Sparkfun, but it's not officially from Sparkfun, and he said he just put in a few interesting boards which maybe can be interesting for me. And here we have a ESP82, no, here we have a ESP32 board, very nice. Even nicer, an ESP32 with a LoRa board, very interesting. And I saw an interesting one too. Oh, this seems to be a nice LCD display. I have to have a closer look at it later on. And this is a Arduino compatible, I assume, but one I even got some, not sure if these work, they are untested, so really from the internals of Sparkfun. And I think this is an, yeah, here it is a L1, this is a VL53L1X, so it is a more powerful distance sensor. Very interesting stuff here, lots to do. What the hell is this? Oh, a TensorFlow, powered by TensorFlow. So this is probably a whole video on its own. This is an Wi-Fi IR blaster, which is an ESP8266 and some IR diodes. Interesting. I did already a video about that. And an AT-Tiny 84 with a bootloader, which is also interesting because it looks like we can connect it to a USB, but one is quite interesting, and this is this one here, the SPX whatever, but it has an AS3935 lightning detector, and this is an interesting chip. If I remember right, it comes from Austria. And the second interesting thing here, it's a quick interface, and this is another new standard from Sparkfun, as I understood. It is I2C, and it should allow us to standardize more or less most of the modules here. So I will have a look also at this quick interface when I do the lightning detector thing. I got already one of those AS3935 lightning detectors in one of my earlier mailbags. Now I have a second one to compare. And here I assume these are these quick connectors. Yes, these are these quick connectors where we can either use it for our breakout boards or quick to quick. This is also a quick joystick, and this is a quick Phat where we have 1, 2, 3, 4 I2C interfaces for our Raspberry Pi. Very interesting stuff here. So here it's a letter from Wes where he describes the situation, and he says happy hacking. For sure we will have a happy hacking with all these things. Thank you, Wes, for your contribution for the channel. This is all I had for today. I hope this video was useful or at least interesting for you. If true, please consider supporting the channel to secure its future existence. You'll find the links in the description. Thank you. Bye.